Starting now, and I'm looking at the two sections of the Arduino IDE, and we are having void setup. Then you also have void loop. So please know that for void setup, or as I indicated earlier, we are supposed to be using concepts from C++ and I was indicating that it's based on C programming and C++, just some concepts which are borrowed from the same. And we have void setup, then there is void loop. Now, what do you mean by void setup and what do you mean by void loop? And a void setup is where we are going to put the initialization, as in the ports. All these ports that we have here, you need to tell the system that this is the one you are going to deal with, particularly as an output or an input, and also these ones. So this is where you put them, plus also the serial monitor. There's something we call the serial monitor, which is down here. Of course, with the actual Arduino, there is also a way that you access it, which is slightly different. So then the loop is where you put anything that you want to run continuously. So this one, you initialize your devices, you declare them. This one, you are going to have something done very many times, so long as the system is on. So let's start, and I will write, of course, some short notes. Of course, like now, this one is a comment, and we indicate this is where all the input and output ports. So where the input and output ports are initialized or declared. So they basically include the output, digital input and output. So digital input and output. Please note that these are digital, which start, of course, from 0, 0 all the way to 13. This one on the upper part. Then, as well as the analog, inputs and outputs. And I hope you're also writing from your side, so that we understand. But our analog will be mainly the inputs, A0 all the way to A5, which are down here, and analog outputs will be the digital output, which are pulse width modulated, and that will be 3. The ones which have water tilde, 5, 6. Then 9 to 11. So when you're asking a question, I think maybe this is what the clarification you might have wanted, and that's how it's supposed to be. So as I indicated, I think you have done you've said the serial monitor will be declared here. Then we have also the digital inputs and outputs, as well as the analog inputs and outputs. Have shown which ones we are talking about. The 3, 5, 6, 9, 11 to 11 are the PWM, call them pulse width modulation, as I explained some time back. So use the command pin mod to be able to do that, and that command would be having M as caps, pin, so pin, which means the ports, and then of course M is our capital letter, and then of course the mod. The mod means you're going to have it either as input or output, and I can take maybe 2, just an arbitrary value 2, and I say output. So I've actually declared the digital pin 2 as output. So digital pin 2 as output. That's what I've done with this. Then you can also do digital pin maybe 13 as input. You could do that, but you need to note that it's either any of them, any of these ports can be input or output. Though sometimes we prefer using from 2 to 13 because 0 and 1 can sometimes be used for receiving and transmitting, but still you can also have them as your inputs and outputs as well. So 13 input, that's an arbitrary value also. We take 13 as input. So you will have declared, you can note that the additional thing here to note or to understand is we are going to have an output, you also have input. That's for digital. What about analog? You can also have the same. You can have them as input and output. And to make our work easier, I'll just copy and paste these ones so that you guys, you don't have to do a lot of writing. So pin mode remains, but now I will take 3, one of them, either 3, 5, 6, 9, 10, 11, which are the pulse width modulation. Actually, the digital outputs which are used as analog outputs. So that when you're going to write your program at some point, you use analog write to transfer what you have here to the output. So then we change this. I've said output, then digital pin 2, 3 this time as analog output. And then I can change for input to A, and it means you are taking these A's, A0 to A5. So analog pin A0 as input. You can call it as analog input. This one's digital pin 2 as digital output. And this one we have it as digital out input as well, digital, so you can change, you can just put them that way. And then the serial monitor, how do you declare the serial monitor? We use serial dot begin, then we have 9600. So we say here initialize or declare the serial monitor, and 9600 represents the rate. So 9600 represents the data rate in bits per second. So by the way, these are the 5 most important commands that you come across in void setup. In fact, I don't think whether I'll be having any other command apart from maybe in a case where we're having the LCD, and also sometimes when you're using libraries, that's the only time you can have something different slightly. But these are the commands which I want you to get hold of. When you are dealing with Arduino, in the void setup section, you don't need much. Just get these 5 commands and you are sorted. And that's why I say sometimes it's very easy. We are not supposed to have it difficult understanding. I think it's the attitude that we usually have to programming that makes us resistant. But otherwise, there is more of high-level language, very close to our language, which you understand. You can see pin, mode, output, input. These are things that you come across. Serial, begin, yes. So 9600 numbers we have dealt with, and that way we don't expect things to be that difficult. So under void loop, where now you want something to run continuously or to happen continuously, this is what you're supposed to do. What can you have running continuously? You can read, you can write, so you can be able to do those. You can also print. You can delay. You can turn. Okay, sometimes you can map. Like now when you want to transform some range of values to another range, you usually say map. And in some cases you can you can generate random numbers and randomize, maybe you can say randomize numbers. But with my case, we are likely to be using the first 5 commands. So reading, what are you doing? You are getting the sensed value. So you're getting the sensed value and storing it in a variable. Which means you also need to know a bit of the data structures like int, double, float, and so on. You can use them, but most commonly we'll be using the int. So in which case, if you take an example, you say int, then we have a variable onto which we are going to store the value that we are reading. So you can also do digital or analog read. So in this case, I can start with digital read, and please remember our digital input was 13. So which means you will connect a device to 13, which will giving you, which you are going to use to sense, or which will be giving you the sensed digital value. And an example of that such is the button switch, which you are going to use. So you digital read from 13, because that's what you declared here as the input, and then close. So in this case, you can comment and say read sensed digital value from sensor connected to 13 from digital input 13 and store the value in variable A. So that's what you have done. Int, of course, is the data structure which you know what to represent. You're going to have integers only. Double, it can give you, of course, up to 2 points. Binary, two decimal points. Then you can also do the same to analog. So we can still copy to make it easier. And I'm going to change this to B. Then we do analog read. And you're reading your analog from A0. So because that's where you say you connected to your analog input. So you read the sensed analog value from the analog sensor on the analog input A0 and store the value in variable B. So we have done the analog read, we have done the digital read. So please know that this value can either be 0 or 1, and this value can be from 0 to 1023. So we could indicate that the sensed digital value, it can either be 0 or 1, and the sensed analog value can be from 0 all the way to 1023, so 1023. So that's what we have. And then for that's usually for reading. Write, you're going to write onto an output. In most cases, you can also do analog or digital write. This one you can say analog, or you can start with digital or analog. So you can also write analog. I think we can copy this and paste. Please copy the first one to make our work easier. Then we'll be changing. In fact, you can even copy everything here. And we change them accordingly. So you can say here write, and you can write digital or analog. This one you are transferring a digital value into the output. So transfer a digital or analog value onto the output. So here you are not going to use the int, you just now be writing. So you can remove these ones, but let's just go line by line. So you can have digital write. So we have digital write, and then our output, which was digital, is 3. So you have this 3 comma, and then you put A, which means what you had read from here, which was either 0 or 1, is put here. If you have the values and you want to put maybe just 0 or 1, you can put here 0, which means it will be off. You can put it 1, which means it will be on. So sometimes you can use that, or you can even use low and high, because this one recognizes the two. You can either use 0 or 1. You can use A because A has got a 0 or 1 within it. But you can use a 0 depending on whether you want it constant, or you can use a 1, or you can use a low or a high. So for this one, transfer sensed value 0 or 1, which is in A, transfer sensed value 0 or 1 onto digital output. Three. So digital output pin, you can call it even pin here, no problem. So this time we are not storing anything. We're just transferring it. Correct. So we change digital write will be 2, not 3. Because up here we declared 2 as our digital pin output. So we actually change it to 2. Thank you for the correction. So here we put pin 3, pin 2 instead of 3. 3 will be the analog one actually. That's very good. Then for analog write, now that's when we'll be using 3. And here we say analog write. This time we are going to use 3, then put comma, and then the value in B, or whichever value you want to put here. But most of the time we transfer the value you are reading from the inputs. So transfer, you could as well just copy this and paste it here, and you will change that to so transfer sensed value, sensed analog value. Sometimes you can complete the word that way. 0 to 1023. onto the analog output. It's actually a digital pulse width modulated output. So sometimes you can call it that way, digital PWM. The PWM is what changes it to analog. So PWM output pin 3. So you can actually even have a code that way, so that we see everything. Behind it, we know it's Arduino that we are dealing with. So analog write 3B transfer the sensed analog value 0 to 1023, which you read from here. You read here. You had read it from here. And then now you are transferring it onto the output. And that's what I think we can put in the right digital or analog. Then print. Now in most cases you will be printing these values. You can print these values that you have done. Sometimes you can print them immediately after you read. So the command will be serial dot print ln. If you just want to print the value and that's all, then that's what you do. And you put A, because that's what you had read here, to see what it is. So here we are displaying the value. So display the digital sensed value. A. The other one you can also do for B. Display the analog sensed value. B. And for sure, when you are going to check in the serial monitor, you will see your values displayed. But later we can be able to see on how you can print a character. Of course, if you want to print a character first, you can do serial.print print only. So like this one, if I wanted to print, I can do serial.print. You don't put ln, just print, not in the next line, just in the same line, it will print the next one there. And you have the double inverted commas. Then you put A is equals to, which means it will print this, then print the value of A there, and then. If you want for B, you do the same. So this one display display A is equals to. Sometimes it's not a must. You can just, if you know what you are dealing with, it's not a must. So here you display B is equals to. So when you are printing, you can print either digital or analog. That one you don't need to specify. You are just printing something out. The only thing you need to specify is whether you want to print a character, like what I'm having inside here, or you want to print an integer, whatever is inside the variable. So under delay, please note that here you are waiting, so you can give the meaning of this. So for this one you are displaying. For print you are displaying. Display on the serial monitor. So for this one you are waiting. As it displays, you wait for a given time. So it's just a simple command. You just do delay, and please note that the syntax, there's no caps. Then you put 1000. Whatever is in brackets is the time in milliseconds. So delay, wait. It means wait for 1000 milliseconds or 1 second. So usually, 1000 milliseconds will change to 1 second. So just as simple as that, nothing else that you need to add. Then under tone, this one you're going to use a buzzer, and in the buzzer you're going to apply a frequency. So apply a frequency of a given value onto a buzzer, of course, connected to a given port. The port will be an output port. So like now here I can say tone. This is for analog. By the way, when you want analog value, you apply it. So you turn, like I can say, if my buzzer is the one which is connected to 2, this output here, because you can have an LED or you can have a buzzer. Then you apply the particular value there, which is this time when you are applying a frequency, it doesn't matter where you connect your buzzer. So in this case, you're going to have B, because B is our frequency. Sometimes you can map. So we are going to see you can map also this value to some range. Then you also apply. So here you're indicating apply a frequency of value in B onto the buzzer, connected to digital ports, digital port 2 or pin 2. The next one is map. Sometimes you can be required to map a value. Like now, if I want the value 1023 to change to maybe up to 20,000, then I can actually do the map. And this is how you map. So this one is to translate values, transform value ranges from one range to another. So how does the command look like? Just apply map Though sometimes you need to store that in a variable also, int. This time you can say C there is equals to, then in brackets, I can map the 0, 0, 10, 23. So I need those arguments. Then, of course, this is A. Sorry, it's B, the value we have in B. So we know the value we have in B is from 0 to 10, 23. So you indicate B, then you indicate the range, then to which other range you want it. And I said you can have it from 0 to 20,000. And for sure it will be able to transform and show you. And you can even be able to print it out. So transform 0 to 1023 all the way to 0 to 20,000. Like that. Then the other one you might come across is randomize. You can actually be able to generate random numbers. Sometimes you can do. So this generates random numbers. So you can also have a command, and the command will be so random. You can also store that in a variable. Then you can say int d is equals to random brackets 0 2. Please note that if I put 0 2, usually the second the upper limit is not included. The 0 is included, but 2 is not included. You just have it giving us up to 1. So it will be 0 and 1. And if I want the range to be from 0 to 1023, then I need to put here 1024. So 0, 1024. Then it can give me all those random values. It will generate them. Then you say d is equals random 0 2. This is when you want like a software input. You have not connected any device to the digital input. So in that case, you can say we say here random. So we comment and say that generate random numbers 0 to 2, and noting that 2 is not included. So that means for this case we are doing 0 and 1 only. That's for this case. Please note that these are the commands that I use when I'm teaching computer organization. If I'm teaching digital electronics, if I'm teaching software, hardware and software practicum, because I usually teach even that one. If I'm teaching operating systems, though I've not taught it there, but I usually teach it operating systems and I use this. In fact, surprisingly, operating system is the unit that I actually used the first time to teach using this concept. Then I started implementing the concept in the other subjects and the other courses. And you realize that the subject becomes very practical. They become very practical, where the students are able to appreciate what's really happening, and most of the computer science students, because you do programming a lot. Now you want to relate to the hardware, and it works very, very well. That's all. Unless there's something maybe that I've forgotten, a small thing which most probably you can be able to capture as time goes by. But these are the main commands, and if you count them, they are actually adding to 1, 2, 3, 4, 5, because serial.print is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Those are just 15 commands. So you can get hold of them and they are sorted. But then if we run it, if we run it still, it will give us some results. So if you want to run it, you just go here, start simulation, because you realize we had commented everything that you don't want to appear in the program. And anything that you want in the program, you can see the color it appears in. So now if you want to run your code, you just start simulation. And I know from your side, you guys, you might be having errors. But it's okay. So you can see here, it's printing for me the values A and B. But then if I wanted to print the values for C and D, I also just do this. I copy this. Maybe you can also do the same so that we see how they print all those values. So this one I changed to C caps. I change this to C caps. Then I do the same to D. So D caps, D caps, and you can change these values to D. Then this one to C. Like that. So if you want to see how they appear, you're going to have 4 values. You can see they are there. But for clear view between them, you can put here, you can remove that delay, or you can as well take the delay and put another one down here, no problem. Or you can just put one delay down here. And you delay for 1 second. Though sometimes you could also want to print just a space to separate the two. So at this location you can do serial.print n, then you don't print anything. That will print for us a space. And then that way, when you run the program, you'll see it separating. So that is A, B, D. You can see D is coming either 0 or 1 because of the randomization that we talked about. Yeah. Then B and C are related. The value of C will be the mapped value of B. Yeah. Then A, I've not read anything from an input, so that's why it's 0. It can't change because I've not put anything that you're going to read. But you can see D changes from 0 to 1, 0 to 1 at some point, depending on the random. Yeah, you can see like now it's 0, another time to come 0, 1. So it's randomized. Yeah. It's actually what is based on Tinkercad. This is when you based it on Tinkercad. If you have the actual Arduino, you just need to connect it also, and then use maybe I can do that. With the actual Arduino, you just need to connect the actual Arduino to the USB ports. But I think that we can do it another time. Let's just work with the one for this. Though, with the actual Arduino, you just copy this. The moment you get the interface, copy it and place it there and then upload. And it will just be able to work in a similar way. No difference. No difference at all.